We back? We back. All right, cool. All right. Had to take care of some chores, do some laundry. Although, I think I'm just going to try and wrap up where we left off. Yeah, I got about 14 minutes left, and then pick up again tomorrow. So, now, let's get into it. All right. So, we got. Okay, cool. Where did we leave off? Get somewhere. Yeah, there we go. My stuff's broken. Hold on. Oh. There we go. Oh, jeez. Slightly dying. All right. Okay.
So we can easily go back into our visual, and when we receive the grid, let's simply subscribe to that event. So grid on grid value changed. Let's subscribe to that event, and when that event is fired, we simply update our heat map.
Alright, so where we at? So in our heat map over here. We're gonna come over here, we're gonna do grid on grid value change plus equals grid on ew. Ah, it's a function. Interesting. Grid value changed. Down here. We say private void grid on grid value changed. Object center grid dots up. There we go. Heat map visual.
And that should do it. Very simple.
All right, let's go back, get some context real quick.
Implies this is fired right when some value on the grid changes. So there it is down here on the set value. You can see we set the value and then we fire this event. So we can easily go back into our visual, and when we receive the grid, let's simply subscribe to that event. So grid on grid value changed. Let's subscribe to that event, and when that event is fired, we simply update our heat map. And that should do it. Very simple, and this clearly shows you the power of events. So let's just add a debug.log to make sure our event is firing just like that.
Debug.log grid on grid value changed. Blam.
This. Okay, let's see. Okay, here we are. Let's click and see if the event is fired. Click, and yep, there you go. Over here on the console, you can see the event's fired. Click here, and yep. Okay, awesome. So,
It's a little weird. I don't think I get rid of it. I mean, it's firing, so that's cool. I wonder if it's because in testing. All right, let's see here. Hold on. Huh. That's not firing anymore. Oh, great. What did I do wrong? Hmm. What did we change? We changed the set value. Oh. It's probably that. Yep. Heard. Her. Cool deal.
So we are correctly capturing our on-value changed event. So now almost everything is set up, we just need to deal with the UV for the quads to match the underlying value. So again, here is the underlying texture. It's a simple texture with 64 pixels on the width and 1 on the height. Now we want the color show to match the underlying value. So with a value of 0, we want to show the black pixel right on the left, and with a value of 100, we want to show the green pixel right on the right. So let's go to our code, and in here, inside our cycle, let's calculate the UV. In order to do that, first we need to know the underlying value. So go into the grid. In order to get the value, let's get the value on the current X and Y. Alright, this is our grid value. Now again, the UV is always set with a normalized value. So in order to calculate that, we need to define the current by the maximum. So we get our float grid value normalized, and we essentially just take our grid value and we divide it by our maximum. Our grid hit map max value. And these are two ends, so again, in order to make sure we don't get any mistakes, we need to convert one of them into a float. Alright, so here we have our normalized value, and with this we can now create our UV vector 2. So a vector 2 for the grid value UV, and it's simply going to be, on the X we pass in the grid value normalized, and on the Y it doesn't matter, so let's just put it at 0. So then here on this function, we have actually two UV fields. We have one on the lower left corner and one for the UV on the upper right corner. However, in this case, we just want to show pretty much a single pixel, so it doesn't matter, let's just put the exact same one on both. So every single vector...
I see. Okay, so... this was to represent the UVs. So since we're changing the UVs, we're going to have to change this. Okay. So it's going to be what? Grid value UV. Grid value UV.
won't show the exact same pixel. Alright, so just like this, it should be working. Let's see. Okay, here we are and everything is black. Alright, now let's click. And there you go, that one went from black to a dark red. Now keep clicking and it starts becoming more yellow as it reaches 50 pure yellow.
There
now
you
keep
go.
clicking and it's now green, green, green. And yep, now it's at 100 pure
Awesome.
green. Alright, awesome. So as the value goes up, so does the color go from red to yellow to green. So now we can set and view values in our heat map. Now, in order to achieve a nice heat map, we should make sure that when we click, we apply more than just on a single grid position. So in this case, we would like, if this one is at 50, to also impact the ones around it. Okay, so let's make a function to add a value to our grid map along with a certain range. So let's go into our grid. Here we have our set values and get value functions. Now let's make a add value. We're going to receive a vector 3 for the world position. Then we're going to receive an int for the target value to add. And let's also receive an int for a range. So here let's start off very simple. First we get the X and Y. Now we just cycle through the entire range. And in here we want to add the value. However, right now we only have a function to set the value. So let's make another nice helper function. And this will be the add value. It takes an int for the X, int for the Y, and then...
Oh. public void add value int x and y. So he's gonna say int what?
Then int for the value. And here, in order to add, it's very simple. We just call get value on the x and y. That gives us our current value, so we increase it by our target value, and we put all this inside a set value. Okay, so there it is, a very nice simple function. It takes the current value and increases it by this amount. Okay, now we can go down here and use it.
Wait, what?
The current value and increases it by this amount.
Oh. Silly me. Because that's only going to be the value itself. It's not the x and y. Makes sense.
Amount. Okay, now we can go down here and use it. So we cycle through the entire range, and we call add value on this x, so origin x plus this x, and we add our value. Alright.
Gotta make it iterate. So for int x equals 0, x less than range, x plus plus. For int y equals 0, y less than range, y plus plus. Value origin x plus x, origin y plus y value.
Alright, this should be working. Let's test it. So for that, let's go into our testing class. And in here, we were doing pretty much the same add value. However, instead of that, let's do the grid.addValue. We're going to use the version that has the range, so pass in the position. Let's put a value of 5 and a range of also 5.
You block. Isn't there a command for blocking this? Let's do this. Grid add value position 5 5.
And up here, let's make our grid bigger, but with smaller nodes. Alright, let's test this. Okay, here it is. Let's move all the way up here. Now let's click right in here. And there you go, we now have a bunch of cells with 5. And if we click again, and there you go, these ones that were in the middle, they increased by 5, so now they have 10. Alright, so we have our nice heat map correctly working. However, the shape that we're using is a square, which isn't very nice. We want a diamond instead. So let's see how we're using the range. Over here on our grid, we're cycling through the x and y, both going from 0 to the range.
It's dope.
But instead of a square, we want a diamond. So let's first
Hey,
make
yo.
a triangle, since a diamond is essentially just 4 triangles put together. So over here, we are cycling through
I wasn't
everything.
paying attention. Sorry, go back.
Diamond is essentially just instead. So let's see how we're using the range. Over here on our grid, we're cycling through the x and y, both going from 0 to the range. But instead of a square, we want a diamond. So let's first make a triangle, since a diamond is essentially just 4 triangles put together. So over here, we are cycling through everything, except on the y cycle, instead of going from 0 to the range, let's go 0 to the range minus the x. So this way, the bigger the x is, the lower the y will go. Let's test.
Bigger the x, the lower the y? Really? My brain didn't understand that. Okay.
Okay, here we are. Let's go and click right down the middle. And there you go. We now have a very nice triangle with a edge size of 5. Alright, awesome. Now to make a diamond, all we need to do is mirror this triangle both left and down. So first let's mirror it to the left. So we also call add value. Except instead of adding on origin plus x, we add on origin minus x. Okay, click. And there you go, we added on the right and on.
Oh, I see what he's doing. Cheeky. So you add value. Origin X plus X. Origin Y plus Y. Get value. Wait, what? That's the same thing. Unless my eyes are deceiving me.
So we also call add value. So instead of adding on, so now to make it that to the left,
Okay,
origin minus X. Okay,
Yeah.
click.
I was like, wait, that doesn't make sense.
On the
You
right
have
and
to
on
do
the left side. However, you can also see that we doubled on the first line, so we need to ignore that. So in here, we only do this if the X is not 0. And yep, there it is. Now we have a right and left triangle. Okay, great. Now for the lower side, we do pretty much the same thing. We do add value on the origin Y minus the Y. And the same thing on minus X and minus Y. So let's see. Okay, click, and there you go. Alright, the shape is correct. Now let's just ignore the zeros. So we only do the Y's if the Y is not 0. And on the minus X, once again do just if the X is not 0. Okay, here.
Wait. Back up, homie. You lost me.
Do just if the X is not 0.
Oh, so you have to do this for everything that's not.
Okay.
Interesting. So for this guy has to get put inside the conditional. This guy has to be put inside the conditional. Wait. Is that if X and Y?
If the X is not 0.
But you already have that statement. Couldn't I just put that up top? I'll try that just because.
Okay, here we are. Now let's try right here down the middle and click. And there you go.
Yeah. Apparently not. Alright, so let's fix that. It's a little weird that I'd have to add this twice. Nope. Alright. Oh man. I have to go to the restroom. Be right back. All right. All right, let's test that out. Oh, I did something wrong. Figure out what it was.
Once again, do just if the x is not 0.
I'm silly. This isn't inside. It's not delete. Let's give it a whirl, huh? Ah, blammo. That's pretty dope. All right.
Okay, here we are. Now let's try right here down the middle and click. And there you go, we have our nice awesome grid, and by clicking we add the value in a diamond pattern. And if we click again, you can see that we add the value where we already had some. So if I click in here, there you go, these that are in between, they also increase. So I can add various and the color all looks very nice. So let's try this out without our debug. So go into the grid and over here just add the show debug into false.
Oh, I don't have my stuff set up for that. So all the debug things. Yeah, that's definitely on the other one. It's okay, we'll get there.
And there it is. Now we just see a giant black square, and if we click, yep, there you go, there's our nice heat map showing all our nice colors. So as we increase, it goes up, and now that one is green, red, and so on. Alright, awesome. Now our heat map is pretty much done. Let's just add one more thing. A version that takes a range, and then the value falls off as it gets towards the end of the range. So down here on the grid, we have this function. Alright, that looks great. However, now let's split the range into two different values. So we're going first to have a full value range. So this is a range where the entire full value is added, and then we also have an int for the total range. So when we go past the full value range, we are going to decrease the value until we reach the total range. Okay, so let's first calculate the amount we're going to lower the value once we go past the full value range. Okay, so we calculate the lower value amount by the difference between the total range and the full value range. Now over here in the cycle, we're going to cycle through the total range. Okay, so then here inside our cycle, let's first calculate where we are on the current radius. So an int for the radius is simply the x plus the y. Then let's also define the value amount that we're going to add. So let's call it the add value amount. And by default, we start off with the full value. Then we test.
Radius. That's not how you spell hint. Radius equals x plus y. And add value amount. Value.
If the radius is bigger than the full value range, if so, then we want to decrease the add value amount by the lower value amount. So we go into add value amount minus equals the lower value amount multiplied by how far we are from the total. So the radius minus our full value range.
Oh shit. Full value amount. Value range. Oh, I never capitalized that. Camel case, please. Why are you so bad? Value range, add value amount, minus equals lower value amount. Man, I can't. Wow. How does one spell? Thinking about chores is all. Let's see.
So as we get past the full value range and towards the total range, it will go down, down, down.
Yes.
So visually, as we approach the edge of our radius, we should be able to see the center in green and becoming more red towards the edges. And down here, instead of the value, we use the add value amount, which has been calculated. Alright, great.
Jeez. How do I change everything below that? Just doing this. Blam, blam, blam.
Down here, let's test it with a really big radius. So first on the value, let's put the full value to be 100.
Jesus.
And for the full value range, let's put something small, so like 5. And for the total range, let's put 40. So for the first 5 positions around where I click, it will have 100. And for the rest, until it hits 40, it will constantly be going down. So we should be able to see a diamond pattern start with green in the center and become red towards the edges. Okay, so to test, let's make our grid a lot.
Wait, what? Let's skip something here. What'd I miss?
The add value amount, which has been calculated. Alright.
World position in. World position in. What? We're on that, homie. Chill. Cease thy anger, creature.
Great. Now in here, let's test it with a really big radius. So first on the value, let's put the full value to be 100. Then for the full value range, let's put something small, so like 5. And for the total range, let's put 40. So for the first 5 positions around where I click, it will have 100. And for the rest, until it hits 40, it will constantly be going down. So we should be able to see a diamond pattern start with green in the center and become red towards the edges. Okay, so to test, let's make our grid a lot bigger. Okay, so here we are.
There's no argument given that corresponds to 3 in. But it's right there, bro. I don't understand. World position in. Oh. Why are there 4? Yeah, that's. Yeah, that's not right.
We are at 100. Or put the yes, we should be able
Muck
to
up
see the center
something.
in green and
Add value, world position, and. Oh, this is not supposed to be there. Good eye,
becoming more red towards the edges. And down here, instead of the value, we use the add value amount, which has been calculated. Alright, great. Down here, let's test it with a really big radius. So first on the value, let's put the full value to be 100. Then for which has been calculated.
Okay, so everything gets changed to that. Alright, gotcha. So this. So total range becomes this. Right. Total range. Cool. Let's see. Oh my god. This grid's a bit big. Well, how about we adjust that a smidge? Let's say we add 100, but we only do the range to say 10. Christ. What's large? Don't need to be that big. Eh. There you go. When you click it, bigger it gets. Impressive. Nice. Nice. We're getting somewhere, guys.
Down here, let's test it with a really big radius. So first on the value, let's put the full value to be 100. Then for the full value range, let's put something small, so like 5. And for the total range, let's put 40. So for the first 5 positions around where I click, it will have 100. And for the rest, until it hits 40, it will constantly be going down. So we should be able to see a diamond pattern start with green in the center and become red towards the edges. Okay, so to test, let's make our grid a lot bigger. Okay, so here we are and everything is black, meaning all of our grid is at 0. And now let's click. And there you go, there's our awesome colored diamond pattern. And if I click somewhere else, like right here on the right, and the radius intersects, you'll be able to see. And yep, there you go, over here where they both intersect, you can see that both values are being added. So when I clicked here, the positions that include both diamonds also increase their underlying values. So here we are with the debug visuals enabled, and now we can see how the numbers change. So let's click in here, and there you go. You can see right down the middle, it's at 100, so it's full, and as we go towards the edge, you can see the number constantly going down. And then if I click here on the side, yep, you can see it goes down, but these have been merged by both diamonds. So click on various sizes, and there you go, you can see the heat map getting very nice. There it is, all our nice numbers. Awesome. Now just one final thing. Over here we have a pretty serious performance issue in our code that we can easily solve. Over here on the heat map visual, we are updating our heat map visual whenever this event is fired. And then here on the grid, when we are creating our diamond pattern, we are essentially calling add value a whole bunch of times. And every time we add, we are triggering that event. So every time we trigger, we are updating the mesh. So essentially when we place, we are updating our mesh about 100 times in a single frame. That is obviously very wasteful and causes your game to hang for quite a bit. So instead, let's only update at the end of each frame where the underlying grid did actually change. So let's go up here, make a private, a boolean, call it update mesh. And then we go down here when the grid value changes, instead of calling this directly, let's simply set the update mesh into true. And then
that we're gonna say update mesh equals true.
We're going to have a private void late update, and in here we test if the update mesh is true, then we set it to false and we update our mesh. So just like that, no matter how many times this event is fired in the same frame, it will only update once at the end of that frame. And if this doesn't change, it doesn't update, so everything is great. Alright, let's see. Okay, here we are, let's try and click, and there you go, everything still works, but now I can click multiple times and the game no longer hangs, since the underlying mesh is only being updated at most once per frame. Awesome! So here it is, our final heat map visualization and the underlying
legit. Let's see if it still works for me. Actually I need to fix this. So I said 40 initially, I need to increase my grid size, I guess. Maximum grid. Alright, let's check it. Probably gonna have to zoom out some. Alright, let's go. It's quite large. Impressive. Alright. Oh man, that's freaking huge. Alright, let's zoom out some. Oh, it's so big. Oh, it's so big. All right. So I click. What a crap, that's big. Mayhaps I made too big. Click, click. Ah, perfect.
For just about anything you want. You can use it, for example, like in Battle Royale Tycoon for making an environment map. So as I place environment objects, the environment becomes better, which gets enjoyed. Environment objects all have a certain value and a certain radius, and when put together they combine into better values. You could also use it as a secondary pathfinding map to tell units which areas should be avoided and which should be desirable. The pathfinding would avoid
that's
red
gonna be
areas
handy.
and move towards green areas. So by now I think you can see how grid maps and heat maps are extremely versatile and can be used in a multitude of situations. So think about how you can apply it to your game. As always, you can download the project file.
Nice. All right. I should really buy his games and play them just to see how they go. But let's see here. All right. So heat map achieved. Next is we got that done. Good job, folks. Another day of achieving. Now what I'm probably going to start doing is going ahead first, go through on my own, and then boot up the stream and then go through it again, because I actually want us to move faster, and nothing's wrong with learning something twice. I learned something new that I dodged the first time. So tomorrow, well, a game comes out tomorrow, Bless Unleash. If anyone's playing, hit me up. But yeah, I'm gonna go over to the powerful generics tomorrow, which should be pretty cool. That allows us to give any type to a square in the grid. Oh, processor's heating up quite a lot. Anyways, that's gonna make things way cooler, where we get to the point where we can actually well, like he said, you can have certain tiles be desirable or not desirable for NPCs or mobs to walk on, but that also allows you to do things like, I don't know, say assign a type grass, and then that is actually more preferable. Grass would always be more preferable to walk on, as opposed to, like, I don't know, mud. Anyways, this is cool. Another day. Good job, folks. I'll see you guys tomorrow.